Hey Algebra 2, this is Mr. Osborne. We're going to be going over multiplying rationals and dividing rationals. The last video you watched was simplifying them. Now we're going to take it to the next step and actually multiplying and dividing. So the steps with multiplying and the steps with dividing are pretty much the same except for the first step. The first step is really the key part. Once you get through that, everything else is the same. So let's take a couple looks. Let's take a look at a problem. So if I have this problem, 12a over 2 times 11 over 14a squared, the first thing I want to do is rewrite the second expression as a fraction. Well, the nice thing about this is it's already in fraction form, so we're good there. Now it says if division, change to a second reciprocal, or change the second to a reciprocal, but this isn't division, this is multiplication. So now, I know that the next step says factor a GCF, but I want you to change it, and I want you to cross out multiply numerator and multiply in denominator, and then right here, I want you to write combine the top and bottom. So after you rewrite it as an expression, you're going to combine the top and the bottom. And we're going to do that with multiplication. But I don't want you to multiply it out. I just want you to combine it into one to make everything into one fraction. So let's show you how to do that. So we're going to combine the 12a and the 11. And it's 12a times 11. And then the bottom, 2 times 14. If you notice, I'm not multiplying 2 times 14 or 12 times 11. I'm just leaving it as is. I'm just making everything into one fraction. Now, next, you want to factor the GCF or use the birthday cake method. So let's break down the 12. If we put that over here, divide by 2, then divide by 2, then divide by 3, and there's our little candle. So if I break down the 12, it's 2 times 3, and then times a, and then this 11 is a prime number, so we can't really break that down. Then let's rewrite the 2, because that's a prime number. And then we know that 14 breaks down to 2 times 7. And then we have a times a, because of the a squared. So now, what you want to do is cancel the like factors. So really, the steps are just like simplifying expressions from the night before. Now, let's cancel the factors. So I can cancel this 2 and this 2, this 2 and this 2. And I can't cancel a 3 because there's no 3 on the bottom. And the next term would be a, and there's one a on the bottom. And then 11, well, I can't cancel 11 because there isn't one on the bottom. So there's nothing else that can cancel out. And remember, I can only cancel one term that's the same on the top and the bottom. Like I can't cancel 2 at a time. I can't cancel like 1, 2, and then 2 2's on the bottom. Only 1, 2 for 1, 2, 1, 2 for 1, 2, 1 a for 1 a. Okay, so now, rewrite what you have left. Well, I have a 3, a 7, 11 up here, and an a. So let's do the top. Now I'll multiply 3 times 11, which is 33. And then the bottom, 7 times a, which is just 7a. And that's it. Next one, we're going to look at a trinomial. So we have r squared plus 4r plus 4 all over r minus 1 times 1 over r plus 2. So again, first step was to rewrite the second expression as a fraction. We're good because it's already a fraction. Then we're going to combine the top and the bottom. So let's do r squared plus 4r plus 4 times 1. Well, that 1 doesn't change anything, so we can just rewrite the top. And then we have r minus 1 times r plus 2. And remember, we want to leave that in fraction form. Factored form, so don't factor that. Sorry, don't FOIL that. And then what we want to do with this is we're going to reverse FOIL. We want to factor it out. Okay, that's why then this step over here I wrote binomials, because that's what we're going to make. 2 binomials on the top. So now we say, okay, well the first term is r squared, so we know the first term will be r. And what two numbers multiply to 4, but also add to 4? well, that would be 2 and 2. And it would have to be positive, so we know that that's going to be plus and plus. And then rewrite the bottom of our rational, which was r minus 1 and r plus 2. And then step 4, cancel the like factors. Well, I have one r2 on the top, and I can cancel, well, I have two r2s, but I can take one and cancel it on the top and cancel one on the bottom. But I can't cancel the other r2. There has to be another r2 down here in order for me to cancel the other one. Okay, so I can cancel 1 for 1. 1 and 1. And then what I'm left with is r plus 2 over r minus 1. And then we're done. Now let's take a look at division. With division, the steps are the same except for the first. So here's the problem, 8k over 5k divided by 4k to the fourth. Now, first step, again, is rewrite the second expression as a fraction. So this time it is not a fraction, so we have to put that over 1. Then it says, if division, change second to the reciprocal. So we're going to change this expression to a reciprocal of that. So let's rewrite the first one. The reciprocal of 4k to the 4 over 1 is the same thing flipped. So now the 1 goes on top, and the 4k to the fourth goes on the bottom. And the other thing that's going to change is the sign in the middle. So when we flip it to the reciprocal, now it becomes multiplication. And that's why we do the reciprocal, because it makes life easier. Okay, so now the steps are the same as before. Combine the top, 8k and 1, well, it's just 8k. And then combine the bottom, 5k times 4k to the fourth. And break it down. And we can use the birthday cake method, or if you just know what they break down to, you can write it out. So we know that 8 breaks down to 2 times 2 times 2 times k over 5 is a prime number, so we can't break that down. 4 is 2 times 2. And then we have 4k's, because it's k to the fourth. Now, you can cancel the like terms. I can cancel 1, 2 on the top with 1, 2 on the bottom. Another 2 on the top with 1, 2 on the bottom. And there's no more 2's to cancel out. So I go to the next term, the k. I can cancel 1k in the top and 1k in the bottom. And that's it. There's nothing else I can cancel out. So now we have to combine them back. So we have a 2 on the top, a 5 and a k here, and 3 more k's. So 2 on the top, a 5, and 4 k's, which makes k to the fourth. Okay, one more problem. Now, let's look at division with a binomial and a trinomial. 5n plus 5 over 5, and then n squared plus 5n over 4. Sorry, plus 4 over 5n plus 20. Now, again, first step with division. Make the second expression a reciprocal. So we're going to flip it. The first one stayed the same. Then we flip the second. The sign in the middle becomes multiplication. And then we flip the other one. So now we have 5n plus 20 on the top, and n squared plus 5n on the bottom, plus 4. Now again, we combine the top and the bottom. So combine the top, I have 5n plus 5, and then multiplied times 5n plus 20. And on the bottom, I have 5 times n plus 5n plus 4. Now what we have to do is factor out each of the binomials and the trinomials. So let's start with the top. Okay, so the top, the first binomial here, we can factor that out a 5. So let's take a 5 out, and then we're left with n plus 1. And the second one here, we can factor out a 5 again, and we're left with n plus 5. Oh, sorry, that's not 5. 4, because 5 times 4 is 20. And then let's go to the bottom. Now we have the 5 on the outside of the trinomial. But now we need to factor this trinomial by doing reverse FOILing. And the first term is n squared, so I know the first two will be n. And what two numbers multiply to 4 but add to 5? Well, it would be 4 and 1. And it would have to be positive. Now the last step is just canceling the like factors. So I have let's start with on the top left. I have a 5 here and a 5 here. I have an n plus 1 here and an n plus 1 here. I don't have any more 5s to cancel out, so I have to leave that 5 alone. And then I have n plus 4 here and n plus 4 here. And the only thing I'm left with is a 5 on the top. And that is just 5. And that's it.